Okay, so today we're talking about lesson 8.1. Just so you can see it. Okay, the idea of a confidence interval. So today we're not going to actually build one really from scratch, but we're going to talk about the concept and work with them and learn how to interpret them, and then we'll eventually learn how to actually build them. So what is a confidence interval? So if you're asking a question, and these are very statistical questions, how long does a battery last on the newest iPhone? That's a very good question. I don't know, but we could try to do some testing and test that. What proportion of college undergraduates attended all their classes last week? Well, I don't think it was 100%. How much does the weight of a quarter-pound hamburger at a fast food restaurant vary after cooking? Okay, so probably would have quite a bit of variation. It probably wouldn't weigh exactly 0.25 pounds. So we could do some testing and determine some of these. But as far as, every iPhone battery, we're not going to test, right? So you take some kind of sample from the population. And that's what we do in stats, right? We take samples from the population of all iPhones. We might take, a small sample of them, measure the battery life, and then make a determination from that about the population. But we don't know the exact answer. Does that make sense? Like, we don't know the true battery life of every iPhone in the population, but we can figure out a sample and then from there draw a conclusion. So it's kind of like a guess we come up with. So just to illustrate this, we did a calculator command, basically where we're taking a sample of size 16. And so you see on the screen there's 16 dots. From a sample. They're randomly sampled, so it's not going to be the same every time we take a sample. And then that line in the middle is the mean of those 16 sampled values. The mean looks to be around 26 right there. So if I take another sample, random sample of 16, so I'm going to make that randomized, and look at that one. The dots are a little bit more spread out. You can see they're even a little bit almost off the screen there. And the average looks to be about 31-ish. If I take another one, wow, I'm going all the way down to 20 or 21. So we've gone all the way from 31 to 21 here. Each time I take a sample, it's going to be a little different, right? This one's 23. Take another sample. This one's 28-ish. So after a while, you begin to get an idea. If you take enough samples, you go, okay, like, that's 34. So I don't know. The true mean might be somewhere in the 20s there, maybe the 30s, 20s or 30s. We might be able to get a little better estimate than that, but that's the idea of what we're doing. We're trying to make an estimate for what the true mean is. And so if we take enough of these, we get a better and better idea of we call that interval the plausible values. Like right now, just doing the few I did, I'd say between 20 and 35 is probably where the true mean resides. Those are plausible values. And so I might make an interval like that. Now there's a way to create this. We'll learn about that. But that's the idea of this, is we're trying to make it create. And actually the mean that was stored in the calculator was 23.8. So, and the mean they came up with was actually a little different than what I just said. They said from 33.8 to 13.8. They'd be reasonably confident that the parameter we're measuring, the population parameter, which ended up being 23.8, would be within that interval from 13.8 to 33.8. So statisticians do this. We make what are called confidence intervals, right? And inside of those are plausible values. So I was thinking the 20s or 30s, somewhere in there. I didn't have any teen results, so I think it would be that small. But it gives an interval of plausible values for a parameter based on sample data. So you're taking samples, analyzing that, and coming up with a range of plausible values called the confidence interval. Okay, there's a trade-off between the amount of confidence we have and how much the interval provides. This is an old Garfield cartoon. Take a look at the weather tomorrow morning. The high temperature between 40 and below zero. 40 below zero and 200 above. Yeah, that's too big of a confidence interval. If a weatherman gave that, this guy's never wrong. yeah, if you make a really big confidence interval, you're never going to be wrong, but it's also not going to be helpful. Like that is the least helpful weather report you could have. So usually we tend to go towards like 90% confident or 95% confident. The most common one's 95%. So that confidence level gives the long run success rate that the confidence intervals correctly calculates that the true mean is going to be in that interval somewhere. So the Gallup polling organization recently asked a random sample of adults the most important financial problem facing their families today. Healthcare costs was the leading the way. That's understandable. Healthcare is surprisingly expensive. Based on this sample, the 95 confidence intervals they came up with was between 10% and 18% of folks would say that healthcare cost is the number one problem facing their family today. So a pretty good chunk of folks would say healthcare is the number one thing, but only about 10 to 18%. We think the true one might be 14%, but we come up with a confidence interval, come up with plausible values of what we think. So this is the script that we use, and you're going to use this. So I would write this down. We are C, or like typically 95% confident the interval from blank to blank captures the true mean of whatever it is we're talking about. In this case, people who would answer healthcare is the largest financial concern. So the true mean percentage of folks who would answer the healthcare is the largest concern. Make sure you're describing the parameter, not statistic. Don't start talking. Say we are. Don't say this. We are 95% confident the interval from blank to blank captures the percentage of folks who answered our question about financial literacy and said that healthcare was number one. No, like it's not the sample we took. It's from the population. We're trying to estimate from all people, all U.S. adults who said healthcare cost was the biggest financial thing. So we're trying to emphasize, it's called a parameter that comes from the population, right? So we're trying to emphasize that. So when you talk, make sure you use that. A large company is concerned that many of its employees are in poor physical condition. That can result in decreased productivity. So they want to say, hey, get in shape. To estimate how many steps employees take per day, on average, the company provides a fitness tracker to 50 randomly selected employees to use for 1 month. My wife's hospital did this, and they got rewarded monetarily for having more steps, actually. After collecting the data, the company statistician reports a 95% confidence interval of 4,547 steps to 8,473 steps. Oh, not even 10,000 steps. Interpret this confidence interval. So we are 95% confident the interval from 4,547 to 8,473 step captures the true mean number of steps per day for all employees at this company, right? So that's the interpretation of the interval, and that's something you need to be able to do. And again, it's just a script, remember? We sometimes write the interval like this with that parentheses, almost looks like an ordered pair, but it's an interval. It's lower bound, comma, upper bound. So the lower bound at the interval is 45.47, and the upper bound is 84.73. And most people's steps at this company are between those 2 points, or at least, actually, I shouldn't say that. It's the mean of employees at that company. So the average is between 45.47 and 84.73. So it doesn't mean, there may be quite a few folks that are outside of that on either end. Some folks are fitness fanatics, and some folks don't walk very much at all. So there would be lots of folks on either side, but the mean should, we think, be in that interval, is what we're saying. This is a little breakdown of the interval. So in the middle of the interval is what's called the point estimate. It's the single estimate, and then the margin of error is to the sides of each one of those. And this is, you oftentimes only hear from the news the point estimate. So when we're about to get into polling season for elections, and when they poll folks, they might say, okay, 35% support candidate B. But really what they mean is 35% plus or minus a margin of error of 3%. So it might be between 32 and 38% support candidate B. So a point estimate is our best guess, but we really want to say it's really a range of values. We're not in the business of guessing exactly what we think. We think exactly 35% of people will vote for this candidate. No, we provide a range of values. We think the true mean percentage of folks who are going to vote for candidate B is going to be between some certain interval called the confidence interval. Okay, so the point estimate is our best guess, but it's unlikely to be correct. We don't think it's going to be correct, but we think that the true mean will be within our confidence interval. Between and in the middle of the confidence interval is the point estimate. So it's our best single number estimate. It is a one number estimate, but on either side we have a margin of error. Oftentimes it might be a plus or minus a certain percentage, like plus or minus 3% or something like that. So that's how it looks. So for example, for the earlier confidence interval about healthcare cost is between 10 and 18%. So the true proportion, we think our point estimate is 14%. That's right in the middle. But we're adding, subtracting 4% to make up our confidence interval in that case. How would we find it? So let's say this is our interval here, or this is, the intervals from 4547 to 8473. So if I add up those numbers, 4547 plus 8473, how do you average two numbers? You add them up, divide by 2, and you get 6510. That's going to be our point estimate here, is the average of those two numbers. The point estimate's in the middle between those two numbers. If I take that number, 6510, and subtract the lower one, that should be our margin of error. So really this is 6510 plus or minus 1963. So you find that number in the middle and find out how much you're adding and subtracting to get to the next term, which is what they did. Right? They averaged the two numbers. That gives you the point estimate, the number in the middle of the confidence level, confidence interval, and then you subtract the smaller one and you get the difference. So this is interesting. So we can actually make decisions about a parameter. We learned that 95% of employees take steps between 4,000 and 8,000 there. Recent health guidelines suggest that people aim for at least 10,000 steps. Yeah, I told you it was low. Based on this interval, is there convincing evidence that the employees of this company are not meeting the average? Well, I think there's convincing evidence. We think the true mean is well below 10,000. In fact, at the higher end of what we think the true mean might be is 8473. At the lower end is 4547. Every number that's a plausible value in that interval is below 10,000. So I am quite confident that this is a problem at this company, that they are, if you consider, if you want everyone to walk at least 10,000 steps, well, there's convincing evidence that people employed at this company are definitely walking less than 10,000. Because there are values. Okay, so then what does the company guidelines suggest the aim is for 8,000 steps per day? Because there are some values that are greater than 8,000 in the plausible values or range there, we don't have convincing evidence that people are taking fewer steps, even though we might be thinking, yeah, our point estimate was less than 8,000, and there's a lot of folks that might be, like the mean might be less than 8,000, but we don't know because 8,000 is a plausible value. So if it's a plausible value, we don't have evidence to say that it's unreasonable. It's a plausible value there. So interpret this confidence interval. A recent survey of a random sample of U.S. adults, if they ever traveled internationally, based on the sample, 95% confidence interval. This is interesting. So 43% to 47% approximately have said they traveled internationally. So that's what the interval is. So we think it's somewhere between there is the true mean. So we are 95% confident. The interval from 43.6% to 47.8% of U.S. adults have traveled internationally. We think that's the true mean here. Calculate the point estimate. So then you would just add up those two numbers. So 0.436 plus 0.478, divide by 2. So we think the point estimate is going to be 45.7% or 0.457. The confidence interval would be, so then you would take that number and subtract the 0.436 to get plus or minus 2.1%. So that's our margin of error would be 2.1% there. Is it plausible a majority of US adults, a majority would consider 50% or more, is 50% in the confidence interval? Absolutely not. We think the true mean is between 43 and 47% there. So we have evidence to say that the true mean proportion, that most adults, the majority of adults, do not travel internationally, which is interesting. That's probably true. Actually, a lot of people have not been out of the country, so that's true. Okay, that's your lesson for today.